anybody remember or tell me how we're going to find the domain? In about a week, we have a test. But remember, we don't have school Thursday or Friday. So it won't be long. It'll be test day. Okay, so when I look at problem A, it is actually the hardest one because it has both problems. Remember, problems are 0 in the denominator. So clearly, x cannot be 2. And the other problem is a radical. So whatever x plus 1 is, it has to be bigger than or equal to 0, which means x has to be bigger than or equal to -1. And you have to write both of those things down. You do not need interval notation, but if you want to use it, you can. But it's enough to say, okay, x can't be 2, because I'm not allowed to have a 0 in the denominator. And x plus 1 has to be bigger than 0, which means x has to be bigger than -1. Okay? So what are the two problems again? Domain. The two problems with domain are radical and denominator. So when I look at question B, is there a radical? No. Is there a denominator? No. Therefore, there is no problem. And what's your domain? All real numbers. All real numbers. We're not going to miss that. Don't make it hard. I don't care what's in it. If it's not a radical and it's not a fraction, you're going to say all real numbers. Okay? Now what about C? It has a radical. And whatever is under the radical must be greater than or equal to 0. Which means, if I solve, x must be greater than or equal to 5x. That's your domain. That's C right here, just did it. Whatever is under the radical has to be positive. So I just solve it. I add 5 and divide by 2. So x has to be bigger than or equal to 5/2. Now, find vertical, horizontal, asymptotes, and holes. All right? Here we go. How do we find vertical and horizontal asymptotes? Give me either one for problem A. I guess I could graph them or I could just write them. What's my vertical asymptote going to be? X equals -5. And why is my vertical asymptote at x equals -5? Because that would make the denominator 0, right? And if you don't know anything else in this whole wide world, no, denominators can't be 0. Now what about the horizontal asymptote? The powers match. You have an x on the top and an x on the bottom. So what is your asymptote, your horizontal asymptote? Y equals, 2x over 1x. Y equals 2 is your horizontal asymptote.
So it's whatever's bigger.
Well, it's the fraction, 2x over 1x.
Okay.
The x's cancel, 2 over 1. That's what we do when the powers match, right? So look at B. Just look at B right now. What's the horizontal asymptote? X squared over x squared. What is that? 1. So for B, your horizontal asymptote is y equals 1. But before I go any farther, what had I better do with problem B? Factor it. Because what might happen? We might cancel, and then we would have a hole, right? So let's see if we cancel. Problem is, okay, let's see. Can I factor that top? Minus 5 plus 1. And the bottom is plus 1 minus 1. Uh-oh, see what happens? We gotta cancel. So our problem is x minus 5 over x minus 1. Right?
Yeah. Right.
Okay. Okay. So now where's the hole? Anytime I cancel, I have a hole. Where is it? Hannah, what'd you say? It's an x equal, not 1, x equals -1. It's at the opposite, Hannah. Always when you have x's in those parentheses, you use the opposite number. So your hole is going to be where x is -1, because that's the factor that canceled out.
So you don't equal it to 0 like
You do. But if you say x plus 1 equals 0, what does x end up equaling? Right, yes, that's exactly what you do. So you end up with -1. Now, who remembers how to get the y coordinate? Plug in -1 back here. So that would give me -6 over -2, which is 3.
Wait. Where'd the -1 come from?
That is the factor that we canceled out.
Okay.
The whole comes from the factor that you cancel out.
Okay.
Marley, where'd you chew gum? Okay, now, take a look at what's left. Do I have any vertical asymptotes left after I canceled? Is there anything left down there? Yeah, where's my vertical asymptote? At +1. Why is my vertical asymptote at x equals 1? Because what would happen if you put 1 in down here? You get 0, not allowed. So you break the curve right there, so it can't be 0, or can't be 1. So vertical asymptote, x equals 1, horizontal asymptote, y equals 1, and a hole at -1, 3.
You have to graph the hole.
Actually, on this exercise, you didn't have to, I set up a graph, but I didn't tell you to graph it. But that would be okay, just -1, 3, you just put an open circle there, at -1, 3.
So wait, how do you know when we have to put a hole?
Somebody tell him, how do we know when we have a hole? What,
If there's no.
when you factor your problem, something cancels. As soon as something cancels, you're going to have a hole. If nothing cancels, here. If nothing cancels, like in our first problem, nothing cancels, they don't have any holes. You only have holes when something cancels out. Paul?
And in order to factor both the top and bottom half of factor?
Yes.
Or just
Yes.
have a hole?
Because otherwise you wouldn't be able to cancel. Yep, you gotta factor them both. Okay, so that, kind of look at problem C now, and there are a couple of things different about it. First of all, you can factor the denominator, so I'm going to go ahead and do that. But am I going to have a hole? No, nothing is going to cancel out. Am I going to have any vertical asymptotes? I'm going to have 2 of them. Since nothing canceled out down here, what are the 2 things x can't be? Can't be +2 and can't be -2. So I have holes at 2 and -2. I have holes. Vertical asymptotes. I don't have any holes. These green pants are so tight, they're cutting off circulation in my brain, so it's not working very well. Yeah. Wore these back in 1980 before I had children, and you know, you have 4 kids and things kind of get a little stretched out of place. It's a little bit tight. So -2 and 2 is where my asymptotes are. Now, look at the original problem. What do you notice about the powers?
Bigger on the bottom.
It's bigger on the bottom. They don't match this time. They matched in this problem. They matched in this problem. They don't match now. So what's the rule when the bottom is bigger than the top? Your asymptote is y equals 0. Your horizontal asymptote is y equals 0. Okay? Now, look at D. D is the same problem, but flipped upside down. Will this problem have any holes? No. I factored and nothing canceled. No holes. Will it have any vertical asymptotes? One, the vertical asymptote will be where x equals -1. If it makes the denominator 0, it's a vertical asymptote. Now look at the powers. No holes. Got our vertical. Now I'm looking for horizontal. Look at the powers in the original problem. What do you notice about it? It's bigger on the top. What's the rule for bigger on the top? No horizontal asymptote. So horizontal asymptote, none. When the power is bigger on top, we don't have one. When the power is bigger on the top, we don't have one. That's horizontal asymptote.
Oh, okay.
Okay, now turn it over, because you got to do this side too, and we'll do as much of it as we can. You got to get a quiz in.
Wait, so the quiz was in.
No, so the quiz is going to have on it, this I wanted to get done, review, but the quiz is going to have on it a problem like, I don't know, E, F, or G. Which one do you want to do together, E, F, or G?
G.
G? All right, so your quiz that you're getting ready to take is going to have a piecewise function on it. We are doing G together right now. If we have time after the quiz, we can do some more, but we're doing G together right now. So this is on the quiz. All right, here we go. You remember how we approach this? We start by looking at the top row, we forget everything else and say, okay, y equals 3x. What is that shape-wise? What is y equals 3x? It's a line that has a y-intercept of 0 and a slope of 3/1. So, up 3/1. So I end up with a nice little line. I'm so not good at drawing lines. There we go. But what always happens with these? You don't want the whole thing, do you? Only want a piece of it. So which piece do we want? The part from -2. Which direction? Downward or upward? Downward. So from here down, I want. That's where x is -2, right there. I'm going to erase all of that. All right, then what do? I go to the next line and say y equals x plus 1. What's that? It's the identity moved up one, so it's another line, isn't it? So it's the identity moved up one, so it's going to look like that if I graph the whole thing. Has a y-intercept of 1 and a slope of 1. But I don't want the whole thing. I want the part starting where x is 1. So that would be a closed dot right here, where X is 1. Closed dot. Do I want to shade the bottom part, or do I want to erase the bottom part or the top part? I want to erase the bottom part. So far, so good. What's that? That's a square, which means its shape will be a parabola. So I'm going to graph my parabola. Now this one's tricky because look, we want a chunk of it, right? So we're going to start at -2, and that's going to be a closed dot. So we'll take that dot right there, where X is -2, right there. And we go to where X is 1, so we'll go to here and make an open dot. So it's closed at -2, and it's open at 1. So tell me what to erase. Something has to be erased. Both sides, both arrow pieces are going to get erased.
So the quiz will be over all the back sides.
Okay, no, the quiz, I'm telling, the quiz is this, okay? And then 2 more kinds of problems, so once you practice on the board, which we'll do 1 of each kind. So the quiz you get ready to take has 1 of these on it. You practiced this at the board the other day.
On a piecewise, if we get just y equals 3, is that also a slope?
No, y equals 3 would be a horizontal line.
Okay, but if y equals 3, that's...
And 3 is the slope, yep, yep. Okay, wait, let me do one, look, these, we're not sticking to the paper now, I'm giving you examples of what's on the quiz. X squared plus 2y squared equals 5. Find the implicit functions. Who remembers how to do that? How to find the implicit functions? What do we do?
You move that
What'd you say?
square.
Yeah, we're going to get y by itself. So we'll have 2y squared equals 5 minus x squared. Then we'll have to divide by 2. And then the last step is square root. And when we square root, we say plus or minus. And you can just leave it like that. It's just the square root. Don't try to simplify it. Don't mess with it. Just leave it. Okay? And then the other thing that's on the quiz, the other thing we practiced, anybody happen to remember what we practiced on Friday?
F of g.
Yep, f of x equals 10x plus 1, and g of x equals x squared. Find f of g of 3. So the first thing we do is find g of 3. Well, g of 3 would be what? 9. Then we take this 9 and plug it into f. So the answer would be 91. All right, here comes your quiz. Anybody have a birthday bonus you want to use today? Okay, when is it? June 8th, all right. All right, so Hannah, what's your question? Everybody listen carefully.
Alright, 1 plus 1.
Oh my gosh, 1 plus 1. If you're in a middle seat, you need to move. No BFFs on this seat.
Well, you have to know it for...
Oh, you do for the piecewise, yeah.
That's a BFF.
But it's a basic one, yeah, you're right, you're right. You got me, you are right. But Ethan, please.
Here. What is it?
1 plus 1, what else?
So I just go...
You can sit on the floor or, okay, let's see, yeah, that'll work. This is only the front side. I did not remember to put a name tag on it, so make sure you write your name and the bonus at the top. 1 plus 1. So are you 18 or 17?
Oh, no.
Oh, you're a young one. Sorry, dude. on, why don't we just finish that right now? Get that done for you, since that is one of the things due tomorrow. So we're back on the extra practice 1.3 sheet. And these graphs go really fast. This will not take us long at all. The piecewise are a little bit longer, but these other ones are very fast, if you know your BFFs. So we have A, B, C, D. And then we'll go ahead and do H, I, J, Now, what these problems are all about, and I'm on the extra practice 1.3, what these problems are all about is, do you know what to do with these extra numbers that are stuck in the problem? So when we have the square root of x plus 2, that is not the square root of x plus 2. That isn't what we've got. We've got the 2 hooked right to the x. Who remembers what happens to the picture, Paul?
It moves up on the y-axis.
That would be what this one would do.
I mean, it moves to the left on the
It moves to the left on the x-axis. That's exactly right. So it's our square root function going left 2. This is one of those times when I don't care, honestly, if you understand it or not, you have got to flat out memorize that when you put a plus with x plus something, it's going to go left. X minus something is going to go right. Every time. If it's hooked to the x. Now look at B. Now we've got something hooked to the x, but an extra number too. So what's that going to do?
To the right side.
Right 5. But now, what's that going to do? That's going to go up 1. So this is going right 5, up 1. So I'm going to have my square root picture, my BFF, square root BFF picture, but it's moved over 5 and up 1. And that's all you have to do. You don't have to plot points and all that stuff. You just take the picture you have memorized and move it over. All right, now what about this one? First of all, what shape is it? Parabola, squared. But I stuck a -2 on the end of it. Down 2. So it's your basic parabola. You're not doing anything to it except moving it down 2. Now look at D. A couple of numbers in there. Tell me what this 2 does. Look where it is. It's right there with the x in the parentheses. So it's going to go 2 units to the right. And then up 3. So we're going 2 units to the right and up 3 and graphing our little parabola. This is 2 right, up 3.
Will the parabola ever like flip sides?
Yes, we talked about that. How can we make it go upside down? Put a negative in front of it.
Oh, right.
Put a negative in front of it. Yes. Now, right now, they won't be going sideways. They'll be either up or down. All right, so that's D. Now, I'm skipping the piecewise and going to H. All right, you're supposed to know what e to the x looks like. Make it in the air for me. What does e to the x look like? Yep, that's exactly right. If you want like this, you're exactly right. It is, I'll dash it in here. It's this. That's e to the x. Now, what have I done with that? What have I done with it? Down 1 unit. minus 1 goes down 1 unit. So now the curve is going to look like that. Instead of having 0 as its asymptote, now negative 1 is its asymptote. The whole thing got dropped down 1 step. What's an LN look like? Make it in the air for me. It's the one that goes like this, right? So I'll dash it in here. That's my normal LN picture. Look what I've done though. I've added 2. And where did I add to? In the parentheses with the X. So what does that do? Moves it 2 units to the left. So I'm going to pick that guy up and I'm going to move him 2 units to the left. So now, instead of the asymptote being at 0, now it's over here at negative 2, backed up. Instead of that point being 1, 0, now it's negative 1, 0. Everything got shifted 2 units to the left. You don't have to draw the original in there if you don't want to. I drew it in there just so we remember what it looks like. What's a cube look like? Squiggly through the origin, right? Goes through the origin normally. What is this one going to do? 2 to the right. So it's going to squiggle through that point. Instead of squiggling through the origin like it would normally do, it's squiggling to the right too. Now we're back to a square root. Tell me how it's moving. Right 3, up 4. So right 3, 1, 2, 3, up 4. There's the point 3, 4, and there's my square root shape. Okay, everybody all right with that? Let's quickly see if I can get the other 2 piecewise done. And then this paper will be done for you. It gets turned in tomorrow with your other homework. All right, here we go. What's that top equation look like? It's a parabola. Okay, so I'm going to go ahead and graph my parabola. There's my parabola. Where am I going to put my dot? Where x is 1, that's right here. This is where x is 1, so I'm going to put a nice closed dot right there. Close. And then I got to erase something. Am I going to erase left or right? I'm going to erase right. I'm going to keep left. Less than. What shape is that? It's a line. You can either think of it as the identity moved up 3, or you can think of it as a line with a y-intercept at 3 with a slope of 1. So it would look like that. Either way, that's what it's going to look like. Now, where's my dot go? where X is 1 and Y is 4. That would be right here. It's a nice little open dot. I erase left. So there's my answer. Okay, one more and then this sheet will be done for you. Here we go. What's that top equation? It's a line whose slope is 2 and whose y-intercept is 0. There isn't one. So it starts here, and you're going to count up 2 and over 1, or down 2 and over 1, whichever way you prefer. And there it is. Now where's my dot go? At 0. And it'll be an open dot right there, right? Now I gotta erase something. What am I gonna erase? I'm gonna erase the left side. Because it says greater than. Alright, what's the bottom equation? Is the identity dropped down to? So you can think of it that way if you want. There it is. The identity line drops down 2 units. I want a dot at 0. This time it's going to be a closed dot. And now what am I erasing? I'm erasing to the right. And there's your picture. Okay? All right. Here's, just so you understand, tomorrow, is day 1, right?
Yeah.
Okay, so I'll see you tomorrow. Your homework, 1-1, 1-2, 1-3, 1-4, anything that's listed on that part, not the practice test, not the reviewers, just that stuff, is due, not the flashcards. You don't have to turn in the flashcards. Everything else, including the sheet we just did, is due. Okay? Practice test 1. Tomorrow we're going to do practice test 2. But we have a long period, a little bit longer because it's the lunch period. So we may get practice test 1 done also. If we don't, you will have to do that one on your own. Okay, 1 will be on your own. We'll do 2 and 3 together in class. Okay? So I'll see you tomorrow. And then I'll see you Monday. Your test is going to be Wednesday. Your test will be Wednesday, next Wednesday. Got it?
Time we out of this. We get our credits back to that.
Alright, you think you're done?
I'll see you guys on Monday.
What time we go to the piecewise function, right? Or what time we piecewise it?
Christian, will you turn that off, please? Thank you.